now we're getting to the meat and potatoes of Calculus 1. And what I mean by that is we're going to start using the derivative. We've been looking at theorems and we've spent a lot of time actually finding a derivative, taking derivatives of different functions, and now we're going to use it. So one way we can use it is to determine whether a function is increasing, which means it's moving up, whether it's constant, which just means it's horizontal, it's straight, just like a constant. It's not moving up or down, or if it's decreasing. So that hopefully that's a pretty easy concept. When x moves from left to right, so x is always moving in this direction. If the function is moving up, it's increasing. If it's moving down, it's decreasing, and if it's constant, then it's constant. If it's horizontal, if it's not moving up or down, then it's constant. Okay. So in terms of the derivative, what does this mean? Well, this should look familiar. If the function is increasing, the derivative is positive, right? Positive slope. All these have positive slope. If the function is decreasing, then the derivative is negative. And if it's constant, then the derivative is 0. So we're just saying the same thing that we've been saying over again. We're just labeling it now. So let me actually write those words out just so you see them one time. So increasing, over here this is constant, and then finally we come to decreasing. Okay. So we can use this to figure out when a function is increasing and decreasing, and we can use it to find maximum and minimum points too. If we have a critical number, now we can find out for sure if it's a maximum or a minimum, because we can look and see if we find a critical number. So here's our critical number, c. All we know is that that's a critical number. If we know to the left of the critical number the function's increasing and to the right it's decreasing, then we know it's a maximum. If we know to the left it's decreasing and to the right it's increasing, well then it's a minimum. So let's use all of that, what I just said. So let's do that. So find the intervals on which, and then I'm going to write a function, is increasing and decreasing. Okay, so let's give our function, let's say it's x cubed minus 3x plus 10. Okay, maybe I should make this, I'm going to make this 4x. Or why don't I make it 9x? Okay. Alright, so what are we going to do? Well, first of all, let's take the derivative, because we know that the derivative is going to help us find the slope of the function, and we can use that. So taking the derivative, 3x squared minus 9x. Oh, I should have thought ahead. I didn't want to do 9. I wanted to do, what did I want to do? I wanted to do, let's not call that 9x. Let's call it, I mean, I shouldn't have to make the numbers easy for us, but I'm going to anyways. So let's make this 27x. And then this is just, oops. No, that's all right. Then this is not an x. This is just minus 27 because we took the derivative. Okay, sorry for the hold up. And now we can find the critical numbers of this function pretty easily. We just factor out a 3 and we're left with x squared minus 9. We set that equal to 0. And of course our critical numbers are x equals negative 3 and 3. So hopefully that part is second nature to you by now. Okay, now we can use something called the first derivative test. And what we're going to do is we're going to test the interval to the left of the first critical number, the interval between the two critical numbers, and then the interval to the right of the second critical number. So what am I saying here? I'm going to make a table. And let's see. Yeah, okay. So this is going to be negative infinity to 3. Oh, sorry, to negative 3. We're going to test a number in there to see what happens. And then we're going to test from negative 3 to 3. And then we're going to test from 3 to infinity. And why are we only testing these 3 intervals? Because a function can't change from increasing to decreasing without there being a critical number, right? Because the only way it can do that is if, or an asymptote for that matter, but there's no asymptotes to this graph, so vertical asymptotes, or horizontal for that matter. So the function, to go from increasing to decreasing, as long as the function's continuous, it can only do it in 2 ways. It can have a sharp turn, in which case there's a critical number, or it can have a smooth turn, in which case we know there's a critical number. So that's the only way the function can go from positive slope to negative slope, or increasing to decreasing. So for it to change from increasing to decreasing, it has to happen at a critical number. And since there's only 2 critical numbers, we know this only is going to happen at most twice. Okay, so now what are we going to do? Well, let's take the sine of f prime of x. So all we need to know is the sine of this. We don't even need to know if it's what the value is. We just need to know the sine. So let's test 4. So if we test 4, so here 4 is our test value. So I'm just going to write that in parentheses. And if we plug 4 into the derivative, we're going to get 4 squared, which is 16, times 3, which is 48. And 48 minus 27 is positive. Okay, then from negative 3 to 3, well, let's pick an easy number. Let's pick 0. And if we test 0, then we are going to get 0 minus 27, which of course is negative. And then we're going to test a new value. So let's test positive 4. We know we're going to get the same answer, because positive 4 squared is 16 times 3, which is 48 minus 27. Well, this is positive. So all we need to know is the sign. We don't even need to know the value. Now, that's going to tell us something important. It's going to tell us if this is increasing. So the derivative was positive. That means on this interval, the function is increasing. Here the derivative was negative, so on this interval, the function is decreasing. And here, the derivative is positive, so again, the function is increasing. So we answered the questions. From negative infinity to negative 3, the function's increasing. From negative 3 to 3, the function's decreasing. And from 3 to infinity, the function is increasing. And these are open intervals because at negative 3, the function is actually constant. And at positive 3, the function is constant, right? We already figured out the derivative at those points is equal to 0, which means, of course, the function is constant at that one point. So we're not including negative 3 and 3. So these are open intervals, in case you were wondering about that. Okay, and that's it. And now we know for certain now that negative 3 is a maximum because we went from increasing all the way up to negative 3, and then we got to negative 3, and then to the right of negative 3 we were decreasing. And then we know that 3 is a minimum. So this was negative 3 here. Because to the left of positive 3, sorry, we're decreasing, and to the right of positive 3 we're increasing. So if this is 3 here, we have a minimum. Okay, so that's it. We'll see you in the next video.